Welcome back. My name is Simon, and in this video we're going to look at how state can be handled globally in a Flutter app. We will look at the admin dashboard I tried to build up in this video series, and what I'm using for it is riverpod library, which is a state management library very similar to the provider library, but it has some extra type safety, especially when we use it together with the freeze annotation library, which basically introduces some type extensions to Dart that they're kind of lacking support for. So this freeze annotation package gives us immutable state objects that we then can use with riverpod to make a clean handling of state. Share preferences, the third library in this list, is just used to restore and store state in a browser or on devices without handling all the special cases. In our app, we later want to connect navigation done in a declarative way, as I said in the introduction, and connect it to our global state. So our global state will handle everything that is not only used locally in a widget. So we might have some forms that just use local state. That's actually also possible with riverpod. But everything that has influence how a widget looks like at different places in our app, we want to keep globally. And this means we can also have some custom logic built on that state that we only have to write once. Still, at some points, we want to have state locally in widgets, because having it globally also means everybody can access and we get some tight coupling of all the places where we use that state. Let's start with a very simple example how global state can be useful. For this, we have to understand that this admin interface is not just hard-coded like it looks like. Some parts are for demonstration purposes, but for example, the menu on the left and the kind of model instances we can work on when we go to all events. Also authentication that we have to do before we can see the list is all done in global state. In global state, and it's derived from either APIs or a definition file that specifies how the UI should look like. That is such a YAML file. It's basically translated to JSON later, and it defines some views. In this case, we have our events view. We have another one that is a model create one. So this is the list one. This is the one to create events. You see some title definitions here. So it's quite obvious what happens here. There's some menu item. Also, it's actually kind of separated into what views exist and what menu items exist. And we also have some menu groups down here. So this file gets read once when the app is started and creates how our menu looks like. It also defines later, there's still some attributes missing here, how the information, the models, the structure of the models gets fetched from the backend. Now this UI file has to be read once at the beginning, and it's probably something we want to keep in global state because it's used all over the place. Now let's look at how we can make some visualizations of state, because we use this throughout the course to understand how state flows in our app. So assume our file defining the UI is up here. Let's call UI.yaml. And that file is basically used by the UI state. Now this UI state is, you can imagine it's like not only the definition, but maybe enriched with other information. So it's state that defines what the global state thinks the UI should look like. We can extend this over time Initially, it might just contain a list of menu entries, a list of views that are valid. At some point, though, this has to be read from that file. And this will be when state flows from the file down to the UI state. So this is a one-time and one-direction thing. And we will see this quite often. State should normally flow only in one way. Especially, it should only flow in one way synchronously, because otherwise we create a loop and we'll cycle forever. We'll go on and see what with the UI could happen. Like, once this is read, this has to flow somehow into other state. For example, the UI itself might be something quite constant over the app's lifecycle. So once the UI is loaded, defines all the widgets that has to be shown in the menu, maybe the initial view, so the one that is shown when the app opens the first time. We have to have more control about which page or which view is currently shown to the user, because the UI defines just whatever is there and could be shown in principle. Now, we will see in the next video that we use some declarative routing. And this means we can have our full truth about what views exist and what views are currently loaded. Loaded means having some state associated. We can handle this in global state. And that's why I introduced the view stack. The view stack is the central element, the central state, used by many of the widgets to decide what to display. This view stack is nothing else. So now let's go a little bit into how the state looks like, but not like with code, just visually. This is basically a stack as you know it. It's a very typical data structure from computer science. It's very powerful as well. And it's a stack because we have direction on it, which means we know what is the top. And the assumption is that the user is looking down on the stack, and what he will see finally presented on the screen is just the top layer. Now this view stack, we'll look at the code in a bit, but this view stack can be further influence other state. For example, the main view. The main view is just the layer that we can see, or the user can see. So why is this interesting? Some parts of your application might use the view stack because they're also interested in what layers are underneath. For example, the breadcrumb, because the breadcrumb has to show not only the top layer, but also the ones underneath. So when we have a look, as soon as we navigate into events, we can see that the dashboard is still here, and we can actually, by clicking on it, navigate back, not only by the back button. When we go into create events, we see an interesting thing happening. Even though we just jump to the create events page, we have dashboard and the events list here stacked up. So you get a glimpse from what it means to use declarative routing. But let's go back to the state management. We said the state is flowing from one part to the others. But how exactly is it flowing? Because we also said in the introduction that we're using a package to create immutable state. Immutable state means that you can just do an update on a state on a copy, or while you're updating, you have to create a copy. Why do we do that? It's necessary such that riverpod knows that when an object changes, it actually has to inform all the people that are listening to it, all the widgets that are listening to it. And to make this performant, there need to be a clear criteria when the state changes. And the easiest is to say it doesn't change at all. It is reassigned whenever it changes. So Dart has no real support for immutable states, sadly, but there is a library helping us with not violating that rule, not updating something inside state. Now for our visualization, we will use arrows to display that state is moving, or state copies to be precise, are moving from one state holder or provider to another one. So these boxes are not actually the state, they're the providers holding that state, or you could say managing the state. A little bit confusing it is that they call this notifier because they focus on that this box is also notifying listeners that want to keep informed about updates on that state. Now, how could we draw that arrows? When we start with the UI influencing the view stack, I try to make this kind of clear by differentiating some arrow types. So one is this arrow with a little clock on the top. That clock wants to say that this is just going once over here. So the state held by this provider is just going once to the view stack, and this view stack can be created using that state. Why is that? So we just assume that when the app starts up, so all of this gets created the first time, or some parts first and other parts later, we just have once the UI read from a file or an API, but then it influences how our view stack looks like, but never again after that. So that's why we have the clock. It's basically a feature that resolves once. You will see in the code. Now up here we have something else. It's almost the same in this case, like a feature, but it's actually a stream of state parts because the file reading normally happens in little chunks. But once all the little state parts are read by the UI, this is also never going to happen again. Now, let's look at how the view stack influences the main view. Why? That's pretty obvious. It's the top layer that we are interested in the main view. So this will go down here. But the question is, how many times? Well, the view stack is something more volatile. It can change over time when the user navigates through the app. So that's why we will draw this like this. So we just draw 3 circles, but it is indefinitely many state updates that can flow down to the main view. As you now see already, it's like the granularity of state, the complexity decreases while we're going down this line or tree. For now, it's just one line. But we can especially make this clear when we see the first provider that we actually look at in code, which is the title provider. Let's just call it title. So that's the state. The provider box is called title provider. This is just a term. Could also call it manager, as I said. And also here we want to have indefinitely many updates flowing from the main view to the title. So when you know what is the top layer, you can know what the title of the app is. The title that gets displayed maybe in the bar on the browser, or I don't know, in the title bar of the app or the web app. So when we go to the code, we can switch over here to lib views, and then I guess it's in UI model because I put everything related to global UI state into this one. So this UI model contains all the models. That's the immutable state definitions. And the UI provider holds all the providers. But this is just one choice you can do. You can also move those providers directly close to the widgets. I actually do this sometimes. But for now, because they're pretty heavily used between multiple widgets and even widget trees, I put them separate into those files. Now the UI, let's make that a little bit larger. Let's make more space. Okay, the UI model contains, as I said, these immutable state objects, and what I use here is the freeze library, which allows me to use a generator, generating most of the boring parts for me, basically the copy with method. The copy with method allows me to make copies of the state, just changing one field or two, or arbitrary many, but without having to copy over all the single fields. Now this is the UI box that we saw before, but we are more interested in the title. So the title is actually not even defined here because the title is such an easy object, it's just a string. So let's switch over to the UI provider and see where the title provider is. Here we have it. So the title provider is our very first provider definition that we look at. This title provider is a state provider that's now a riverpod object, and the state it handles is a string. A string is easy to copy, so we don't even need the freeze library here to copy that one. So only for more complex structured objects, we need a freeze library. Now, when we go inside this function, it's actually a function. Well, that's confusing. So we have a provider, which is a variable, but it's actually created from this closure. And this closure gets a ref. So the ref is nothing else than a... Oh, where can I see this? Here, it's a state provider ref. It's one of the central elements, together with the widget ref, as we see in a second, of riverpod. This reference gets passed to anywhere when we need to connect different state managers or state providers. And this ref allows us to read others. Basically, it allows us to build up arrows from our drawing. Now, this actual building of arrows happens in this line with the watch command. The watch method is connecting this very provider to another one. So the other one is the main view provider, as we have seen in our drawing. So the main view provider should influence the title in this way, but actually it's the title provider that makes the relation to the main view provider by saying, I want to get informed whenever this one changes. And there we are at the most interesting method of riverpod, which is the watch command. The watch does say that whenever this updates, we want to have a copy of that state change, or the state with the recent change, inside that variable. And now we can use that variable or the state in it to derive our title provider. So this is run whenever the title provider is requested the first time, but not only then. It's also rerun again whenever this main view provider changes state. That's cool because we can have some logic here that gets automatically re-executed whenever it's necessary, not when we invoke it, but whenever there is state somewhere used, like the title is displayed, and currently we want to have this automatically updated. That's where the reactiveness of a Flutter actually comes into play. Now we have some weird syntax here if you're not used to the freeze library, but it's actually something very similar to a switch statement. I was considering for a long time if I should use the freeze library because it gives some extra bloat, or not actually less bloat, but more challenge for your brain to understand what's happening. But I found it so useful for a reason we see also in a second that I had to do it. Basically, it's exactly that statement. So this map statement is the more advanced and more type-safe switch statement that you know from most languages. A map statement, or a map method here, has 3 arguments, and they correspond to a switch statement. So before you use the freeze library, this might have looked like this. We switch over the main views, or the main view is the controller, the provider, and we switch over this and have some case statements. So the case statements list the different kind of things. Maybe that would be called view type, or view I don't know, kind. So you had some enumeration probably that is called like this, and you would have this resolved here, having multiple cases for all of these kind of things, and so on. So this was how it looked before. And with some nice linters, you can actually see if you have all cases handled, but it's much better this way, because this is a compile time error if you're not handling all of these arguments. They're all required. So what is happening inside here? What are the kind of switch cases that we're going over here? It's resolved, loaded, and not found. So of course, now you have to understand what is my model of such a main view, because such a main view apparently is not just one thing, it can be multiple different things. And Freeze introduces with this pattern actually something that's missing from the core type system of Dart, which is union types. That's a technical term. Union types allow to have something kind of similar to polymorphism, but it's not exactly the same. So it's basically that you can assign different kind of objects that share some attributes or none to the same type. Sounds very similar to what you're used from inheritance. And so let's look how it's actually done inside. So when we look at the map here, no, not at the map, sorry, at the state. So this state here is it's the state of the other provider, of the main view provider, right? So it's the one that we derive our string from. Basically here we see that we are returning a string. This is also a string, and this is also a string. So in the case that something is resolved, the main view is resolved, we return this one and this one when it's loaded. Okay, confusing. Why is there even 3 states? Well, this one makes kind of sense, so let's start with this one. Not found. Okay, the main view can be not found. Now it makes sense, because the URL that the user types into the URL bar might actually be invalid. That's something we do not necessarily know from apps, but in the browser this can happen. So the main view might change to this special subtype of this union type, which is not found. This not found makes us just display a not found text as the title. The title might be used at several places in the app, as I said. So the other two are basically just a difference between I know this URL, I can resolve it to something that is existing usually in my app, something like this is a valid instance, a model instance. Oh, sorry, no, it's a valid model type, but it actually cannot find the concrete instance. So assume you're searching for something like, I don't know, list events, and you say, I want to have the third one, the one with ID 3. So this might be a valid URL so that we can actually resolve it, but we cannot load it because this instance is not existing. We might also go and fall back to the not found case in this case, but I have some special use cases where I need to differentiate between those two guys. So the loaded is the good case. It's the good case where the view is fully loaded and we can retrieve the title directly out of the view. Now, we have a short glimpse at that union type because I think it's interesting. The main view has the state of this provider. So the provider gives us a certain state. Let's go to that provider. Now we see that this is also a state provider, and it provides us this routed view state, basically an optional of it, so it can be null or a routed view. Now, first we see inside this provider that we depend on the view stack. So this is no surprise because we already saw that the view stack influences the main view. Now, when we want to see the type that we are managing here, we have to jump to the routed view, and this is now the one that gets generated by the freeze package. Now, freeze package introduces some weird syntax to your project, but there's no other way to kind of plug this into Dart. And once you get used to it, it's easy. It's basically factory constructors where you have to assign the later generated objects here, classes, and you have to also derive from extends this routed view which is generated. And basically each factory constructor defines a union type when you define it here without underscore. And this makes you separate this routed view type into 3 different subtypes or members of that union type. So it's resolved, loaded, or not found. And now when you look at the arguments, you see that there are some common ones. So this one is common to all 3. Required here, and required here. So the path is always part of these different subtypes. But when you look at the resolved one, you just have a view ID, which is kind of just an identification of a view. And here you have a full view, a loaded view. We're not looking at these types, but basically this one is the more easy one to create. This one contains more information, it's the more complex one. And here we don't have any more arguments because we could actually not even find the view ID associated with that URL. So this is maybe not, well, it's not the, I wouldn't say that I like it so much. Like Kotlin, for example, has a better handling of union types, but when you see the power coming to play, when you now change this, it gets interesting. So let me demonstrate this quickly. So assume I now have a new type here. Well, I might want to handle on this level another type of invalid URLs, and that could be permission denied. Assume I have a routed view that leads to a permission denied error, so it actually exists, but the user cannot see that route. We want to introduce this new subtype, permission denied. And it has also just a path, because we could maybe resolve the view ID, but we don't even want to tell the user what it would be behind, so let's assume it's just path. Now, the cool thing is, we run the generator with flutter-pub run build runner builds. That's how you have to do it. You can read it up on the freeze documentation. And quickly we see, oh, I made a mistake. So basically not found is this name that the generator uses, and I shouldn't reuse it here. Even though this works, this will make them collide. So let's call this permission denied. So let's do this. Yeah. Wow, that's super slow. My computer is really busy with recording. Nice. So now everything is green again. So this compiles again. Nice. But actually there's some red lines here. And what happened? What happened here? The UI provider is no more satisfied. Oh, cool. Map is no more satisfied. Why? Add required argument permission denied. So that is what I meant is hard to get like with other patterns, because it basically, because this map is a generator function, it will be extended by the generator to have the new type. And we have to handle it. Wherever you use that state or its different substates, we have to add this case. So now we have to handle the permission denied case, and we might just handle it by returning a new string called permission denied. We have another case here where it's not satisfied. Aha. Here we use the when. You can read it up. It's just another way to go over the different subtypes. When basically already gives you the contents here. It's a little bit shorter to write when you use all of them. So it's quite similar. So also here we have to add the new case, the permission denied. So I don't really want to go into where we are here. So we are in the new route path. It has to do with navigation. We will see this next time. So for now, just let's be lazy and add it to do. Yeah. Oh, not like this. Cool. That's confusing. Sometimes IDs are in our way. So, yes. And now our app reloads. Well, now compose again. So probably we have no proper handling of permission denied because we're actually never creating that state. So at some point we probably have to create that state, but we're not doing this now. Let's go back to our state diagram once more and understand one more thing. So now we have this one line of influences of state updates propagating from provider to provider. Now, this is not the full truth. We can have something more complex. We can have actually not only a line, we can have a tree. So we can have, of course, multiple boxes depending on the main view. But also, we can have one box depend on multiple other states. Basically, this can be a DAG, a directed acyclic graph. And one of the things that we might want to make our main view dependent on is the not found path. The not found path, let me check if it's called actually like this. Yes, the not found path provider. The not found path provider is also influencing the main view. So let's make it here. What is the not found path? So the not found path keeps the last URL that could not be resolved and not loaded. So here we also want to get updates whenever this changes. This can be helpful to have a separate place in the global state hierarchy where we keep our last path that we did not resolve and have a simpler access. We might even integrate this into this state, but you see in a second why this is easier. Now, when we have the main view run, so the provider runs, initializes its state, it might now depend on both of this. So it's getting updates from both of this, so it means it gets re-executed whenever one of those changes. So when we go to the main view provider, we can see that we have two watch statements within this provider. One is watching the view stack provider and the other one the not found path provider. And we can use a logic on top of those values, current values, to decide what the routed view, the state of this provider, should be. So for example, you see this line, in the condition when the not found path is actually set, we want to return a not found view. So it supersedes everything else that is on the stack. When you go into this provider itself, the not found path provider, first notice that it's just a string that is optional. So the default value is actually null to signal that we have no not found path. That's basically when the app starts. When the app starts, we're going to some initial view and we do not directly direct the user to any URL, maybe the default one, the dashboard. But when the user enters something, this has to be set to something non-null. Now that is the interesting part. Who is setting this not found path away from null? And that's when a new kind of arrow comes into play. The new kind of state update that we can receive is user actions. The user actions are normally coming by button presses, but in this case, it's coming by somebody typing something into the URL field. Maybe with a path. And this one will update our not found path. And now the interesting part to see is that this is something else than we were reading a file, because this actually is initiated by the user. And often these kind of things are handled by something you cannot change easily. It's probably some Flutter framework logic, some Flutter framework support for getting notified when the URL changes. So basically, we don't control how Flutter is telling us this. They might have their own way to notify us about the URL change. And that's why it's cool to have this intermediate not found path provider here. Because this one is quite simple to set. It's just a string. So whenever the interaction between the integration between these two guys here is, it's very simple to just have the implementation of our notifier that handles route changes in the URL bar, just setting that not found path. And the rest will react according to this one. Now, how this exactly works, we will see in the next video when we look at navigation. But for now, let's just have a look at the providers again and notice one more thing. Yes, here, the not found path provider is a state provider, as we have seen many now. But more interestingly, that's not the only kind of providers that we can have. So this is the one to use when you just have a simple state. You can also use this with your own states that are more complex. But one of the main things to notice is that when we want to change this state in a complex way, so basically doing some API calls to mutate the state from something to something else, then where should we do that? I saw some people doing that inside that state. So assume this is not a string. Let's go to our other one, like the main view provider. Some people did this within that state. Having some methods on it is a typical object-oriented design thinking way to have just methods updating the state. But it's not great because inside that state, you have no access to our other providers. And maybe you want to use, for example, authentication tokens whenever you change the state of this state provider. That's why we can use something more advanced than just a state provider. So in this case, we're just deriving it, so here we don't need it. But when you go to the UI provider, even better, we look at the ViewStack provider because we know that one already. That ViewStack provider is a state notifier provider. So it's something more than just a controller of the state. It also has associated logic. I will call this actually controller, but riverpod and the library decided to call this notifier because it's more similar to what people are used from the Flutter notifier, the built-in one. So basically this notifier is an extension to not only have the state, but also a special class to manage it, which is the ViewStack state class. It's down here. It has to derive from StateNotifier, and this class now can hold all this logic around the state. You can also pass a ref here. So you can pass the ref inside that one to make all the other providers accessible from basically the controller around that state, the list of views, our stack. And inside here, we can do stuff like, what is a good example? The pushing. So whenever the stack changes, we see that we can call this methods, and this method will now change its managed state. So at some point we have an assignment to state, assigning it to the modified stack R and some pushed view. All right. But the interesting bit is here. Whenever this happens, we can actually also access other providers and update their state. And what we're doing here is we do update the not found path provider or its state to null. Why is that? Well, when somebody changes the view currently displayed by clicking on a navigation item, we do not want, so we want to forget about the last path that was not found. because it has no more importance for the flow, for the user journey in our app. So here we just had a little glimpse into how navigation works. We just more saw how the view stack works, but how this actually connects to navigation, and especially declarative navigation in the Flutter Navigation 2.0. We will see that in the next video. See you over there.